So Slitscan imagery is generally created by taking just a tiny slice of a video or of a camera frame and then stacking that tiny slice one after another. So here we're taking a source video, and from each frame in that video we're taking the pixels in a column and we're pasting them into a new image. So you can see here we're taking 3 different places from that video and we're generating 3 different images. One cool thing is if you have a stationary camera and you have a moving subject, Slitscan videos and images allow you to track just the moving pieces of your image as it goes by. So with that, let's get started and build this program in Python. So I've already created a directory. Let me open it here. And in this directory, I've created an empty Python file, and I've also added a source video that we're going to be using for the slit scanning. This is a video I took at Lower East Side Skate Park in Manhattan. I think this was an Ikumi fashion show. Anyways, we're going to be using this to do our slit scanning. So the other thing we're going to use besides this video and just an empty Python file is two libraries, kind of 3 libraries. So I'm going to be using something called Pillow, which is the Python imaging library. If you Google search for Pillow, you probably won't find it, so you'll need to do a search for Pillow Python, and then you should be able to find it. And the only tricky thing about installing it is that it has this capital P in Pillow when you use pip to install it. Then the other thing we'll be using is MoviePy. And so MoviePy is going to be used to open up our movie, our source video, and then to take each of those pixels from that movie. And then Pillow, or the Python imaging library, will be used to save out those pixels into a new image. And the third library that's kind of used that we don't really talk too much about or use directly is kind of NumPy. And so NumPy, or NumPy depending on how you pronounce it, is the Python library for addressing numbers really quickly. So it uses basically C objects in order to speed up and parallelize array math. We'll get to it, so if it's a little bit confusing, just hang with it. We'll see NumPy gives you a different way to access arrays and lists than what you would normally see in Python. And MoviePy and Pillow both support saving from and loading those NumPy arrays. Another thing I wanted to show you is just this really great site, Golan Levin. He's got a page just dedicated to slit scan artwork and all the kind of cool effects people have done with slit scanning in general. I'll put a link to this page and just to kind of give you ideas for what's possible and what you can do when you kind of go beyond just the basics that we're going to cover today. So it's a cool resource to kind of get ideas for other things you can do. Alright, that being said, let's start by first pip installing. And I've got to use pip 3 because I'm on OS 10 and I installed Python through pip 3, and I'm going to be using Python 3 for this entire project. So pip 3 install Pillow. And you see I've already got Pillow, and then I can do MoviePy. And so now you'll see and I've also already got MoviePy installed. One of the requirements for MoviePy is actually NumPy, or NumPy. So we've got that installed too. Alright, so let's start this program by first working with the command line. So we're going to take in an argument, which is going to be our video file name. So let's do that really quickly. So in order to do command line arguments, I'm going to use the built-in Python library called argparse. And so the way it works is you create a new variable, with this argument parser function call. And then to that parser, you add arguments. So in our case, we're just going to take in the file name of the video. So the file name of the input video. And if you add this help variable, you'll give the user who tries to run this a kind of helpful tooltip. So I'm going to say file name to generate Slitscan from. And then the way that we get those arguments that are passed in is we do set a variable equal to that parser dot get, or actually parse args. And you can see the tooltips pop up and help me with remembering that. Okay, so that once we got that, let's just check and make sure that that works first. I always like to work in stages where I do one feature at a time, very simple feature, make sure it works, and then move on to the next one. So we're going to do a print opening file %s for slit scanning, and then we'll do %, and then we'll send in our args.filename. And so this add argument takes this string here and converts it into a variable for us in this parse arguments call. So let's save that out and let's try running it. First, I'm going to try running it without any passed in commands. So let's see. Slitscan.py is the name of my program, so let's run it. And then you can see we get this error. The following arguments are required, file name. So if we do python 3 slitscan.py, and then we do the input.mp4, which is our source video, you can see we get that opening file with the file name that we passed in for slit scanning. Cool. So the next thing we want to do is open up that file and get some information about that. So for that, we're going to use MoviePy, and the way that that works, so we go from moviepy.editor, import video file clip. And so video file clip in MoviePy is the way that you access already existing video files. You can also create video files from scratch, frame by frame, but that uses a video clip, which is kind of a little bit different. So anyways, the way that you create a clip is you go clip equals video file clip, and then you just pass in that file name. Cool. So now we can check that that worked and that our library is working, our MoviePy library is working, by doing a %s is %i for integer, frames per second for %i seconds at %s. Okay, that's a lot of %i, %s back and forth. So let's unpack that. We're going to do the argument.filename, just in case we forgot the name of the file from that previous print statement, and then the clip.frames per second, and you can see the tooltip pops up to help me, and then we'll take the clip.duration, right, and then the clip.size. Alright, let's try running that and see if that works. And then I'm pressing up just to get the previous command. And there you go. You can see we got this warning message. Not really much to worry about. There is kind of a problem right now with MoviePy and my my computer, but we won't get into that right now. All right, so input.mp4 is 23 frames per second for 16 seconds at 1920 by 1080. And so one thing to take note of here is we've got 23 frames per second. I believe it's really 24 frames per second. The other thing is, if we wanted to see, let's do this, how far our slit scanning is going to go. If we just take one row of pixels for every frame, we're going to have 23 frames times 16 seconds. We're only going to go 368 pixels wide when we do our slit scan, which isn't going to be filling a full video frame of HD. So depending on your input video, you might have to stretch it out in order to get that big, nice looking clip. And video file clip allows us to stretch our input video to as many frames per second as we like. So if we said, you know what, let's make that into 60 frames per second, we're going to get a 960 pixel wide slit scan image out of this. To make things easy though, I'm going to just make it bigger than our 1920. So let's do 120. Okay. So our if we look at our resolution here, so 1920 is exactly the width that we're looking for at 16 seconds. So that will be our frames per second when we generate frames. Speaking of which, that's probably the next thing we should do. So let's look at how MoviePy works and loads image frames. So Python 3, unfortunately I can't run MoviePy in an IPython session. For some reason it's crashing on my computer, but that's alright. We'll just use Python 3 in the normal interpreter, and we'll kind of play around with the library a little bit. So we're going to do import, actually let's do from moviepy.editor, import video file clip, and now because I'm in the raw Python session, I don't have that autocomplete. Alright, so clip, let's get our focus back, clip equals video file clip, and then we're going to pass in that input.mp4. Alright, so now the way that we get frames from a video is that we do this clip.iterFrames. And then we can pass in a frames per second. So here we can do, like we said before, we're going to go for 120 frames per second. So again, each pixel from each frame gives us 1 pixel width, right? So in order to fill that HD source image video into an HD output image, we're going to have that same width, which again is 1920. So FPS equals 120. And then we're going to do a dtype equals uint8. And so what that means is we want an 8-bit unsigned integer. That's going to give us values for red, green, and blue in our image of 0 to 255. So let's just do that. Let's set a variable equal to that, and we'll call it movieGen equals. And so now we can say movieGen, and then it tells us, oh, this is a generator object of clip.iterFrames generator, okay? And so the way that generators work in Python is that they, on demand, each time they're called, will create a instance of the current variable. So if we do next movieGen, and next is a built-in function in Python, we'll get the very first frame. So I can set first frame equals next movieGen. So if we do first frame, and we type it correctly, we get back this NumPy array, and we can do, and so you see here that it's going to be a bunch of 3 integer values. So this is red, green, and blue for each one of the pixels there. So we can do a first frame dot shape, and we can see that this frame is 1920 pixels by 1080 pixels by 3 pixels. Now I said pixels, but what I really meant is these integers, these uint8s. Okay, so the way that we address elements in this, which is a NumPy array, is we do what's called slicing, and we have commas. And this is a little bit different because if this was a normal Python list, you could access these elements, you know, with this array here, this array here, and this array here. But instead, we do all of that within one. And this is kind of one of those NumPy features. So if we do first frame, and then we do, remember that it goes the height, and then the width, and then the red, green, and blue. So if we do take all the height, and this colon just says slice and give me everything, and then we take just the 1920 integer divided by 2, and then we do give me the rest. Oh, well, we're not function. We need to have brackets here. So yeah, we're still a list. So we do that, and we get back the entire column of our values to take. So this right here gives us exactly the column that we need. So let's create a, let's just, while we're here, let's import NumPy as np, and then the way that we can create a NumPy image to start with is we do numpy.zeros, and then we can pass in a shape. So the shape of our other array is 1080, 1920, 3. And then we're going to do a D type so that we keep the same type, uint 8. And then we get back this, so let's set that to something. So other image equals np.zeros. And then now we can do other image.shape. And then we can do this and set our other image to be equal to the value at that same place. And so the way that we save out images is we do from pill, which is pillow, import image, and then we can do image.from, and then we want array, and then let's do other image, right? And then we'll do output equals, we'll set this output image, and then we'll do output dot, and then I think it's save, yeah, dot save output dot png. All right, now let's see if we can get that file and see if it worked. All right, there we go, our single pixel all the way down. So we grabbed our pixel, we know what we're doing, we know we have a generator. Let's jump back into the code and let's work with what we just built. All right, so I'm gonna exit from this Python. All right, so what did we do here? If we scroll back up through our history, we can see everything we did, right? We can say, okay, we had this generator, we had the clip.iterFrames, so we can do a clip.interFrames, frames per second. Let's copy that, right? And sometimes I will keep an open IPython session while I'm working through something, just so I can kind of bounce back and forth and make sure I'm getting my syntax right. So let's do for I in clip, and so I'm going to paste in, right? So this is going to go through each of the frames, right? The way that we can iterate over this generator is with this for loop, and so this is going to give set I to be equal to each one of the frames for all of the frames for 120 frames per second. So we can do, first let's check and make sure that we're not filling something bigger than the area of the image. So so if the current x is less than the clip.size, and then we want our so our clip.size is different from the NumPy array that we get for each frame, right? I think if we scroll up here, we can see what it's set to. So it says 1920 by 1080. So the clip.size is going to be 0, right? And that's going to be our 1920, which is how big we want our image. Our output image is going to be the same shape as our input video resolution. All right, so if current x clip size, and then I'm going to do this thing here where I'm going to add a slit width. So we can say, like, no, I don't want a 1 pixel wide. I want a 2 pixel wide, or I want a 3 pixel wide. So let's create those variables. So current x equals 0, slit width equals 1. And then we had this np.zeros that we used to create our source image. So let's do that. Image equals np.zeros, and there's no e at the end, it's just zeros. Clip.size 1. And remember that NumPy and these images for pillow have the y first and then the x. It's a little bit confusing bouncing back and forth between the two. Clip.size 0, and then we want 3, and then again we're going to do that dtype equals uint 8. Okay, so that creates a blank black image for us to paste in each frame's individual pixel column. All right. So then one more thing we need to do is set a slit point. So I'm going to create a new variable for that too. So slit point equals clip.size. Again, this is the 0th, but on our output image, it's going to be this position right here. Clip.size 0, and let's just take the center. That's the easiest one to do. And again, I'm using the integer division here because you can't have a decimal for a pixel access, right? You can only do instead increments of round integers. All right, so as long as we're writing to a place less than our clip size, plus that slit width, if we're doing 3 slits at a time, we're going to set image. The column's going to stay the same, right? And then we're going to change the current x to the current x plus slit width. Oh, not that, not the slit point, slit width. And then we're going to keep the other one the same. And then for the other one, we're going to do the current frame, which is I. We're going to take the slit point to the slit point plus slit width, and then the rest of it, okay? And then we do current x plus equals slit width. All right, and then, so that's going to iterate over all the frames, and our blank image is going to be filled from left to right as we progress through the frames with the slit width worth of pixels at a time. So now after that, we've got a NumPy array, and we can do that Python imaging library, right? Did we import that? No, let's do that now. All right, we also didn't import NumPy, so let's do that too. Import NumPy as np, and then let's do from Python imaging library. That's pillow again. It's different capitalization, different usage for every way you use it. Import image. All right, so we've got NumPy as np exposed, which is how we create these np zeros. And then we've also got this image, so we can do output equals image dot from array, and then that image we created here that was set to zeros, that we added this slit width, and now we can do output dot save, and I always like to save as png. It seems to always be output one.png, so we can see our old image too. So now if I scroll down and I save this, it doesn't look like we have any errors. Let's try running it. And this might take a second on your computer, depending on your second setup. So if we look at our output, great, we have something. It's sort of pixelated, kind of distorted, but one cool thing about this is you can actually see the people walking through each way. And if I hold up the source video, you can see there's a point where right here where somebody walks by and totally obscures the entire camera. So let's watch this again. So slowing it down allows us to get these features of people walking back and forth. And there's the guy taking over the entire frame for a bit. Cool. So this is just kind of a beginning. We could also take vertical frames and go the other way. We could change our slit width. Let's do that now. Let's try changing our frames per second to 60 and our slit width to 2. Let's see if that still works. And let's actually change our output too. Let's change it to output 2 so we can compare and contrast the two and see how that changes the effects. Open period, do output 2, and we do output 1. You can see they're pretty similar. Maybe output 1 has a little bit more facial detail. Maybe. Then again, maybe not. I think they're both kind of doing the same thing where they're stepping in between to fill in frames, because again, our frames don't really match what we've got exactly. All right, well, thanks for watching. I hope you enjoyed it. Hope you learned something. Yeah, if you want to learn more, go to my site, Make Art with Python. There's a bunch more projects with things like this.